An introduction to graphing systems of equations. There are two forms of equations we have to remember. The first is the slope-intercept form. The second is the standard form. I would like to start the introduction off by going over and reviewing slope-intercept form of linear equations. In our class, we've talked about y equal delta y over delta x, x plus c, which is also known as y equal mx plus b. We look at the delta y over delta x, that's our slope, also known as m, and we look at the constant values as where it crosses the y-intercept. That's why we call it the slope-intercept form. With specific examples, we might see something like y equals negative 1/2 x plus 3. We want to be able to pull out a nice starting point, and that comes from the c value. That means that I can start on my graph at the point 0, 3. You plug 0 in for x and you get 3 out for y. And then I can follow the slope, telling me to go negative 1/2. That means I go down 1 unit, right 2. Remember, the top number, delta y, tells you to go up or down, and the bottom number tells you to go right or left. I want to do a second example of this just to review. What happens if I said that I had y equals 3/4 x plus 7? I start with a nice point. From this form, I know I plug 0 in for x, and I get out 7. That tells me to go 7 units up on the y-axis, put a point, and then I follow my slope. On my slope, it's going to be up 3, right 4, up 3, right 4, up 3, right 4. The opposite would be down 3, left 4, which is also acceptable. We'll look specifically at these in the next couple of examples. All I want to do with the introduction here is to refresh our ideas of what slope-intercept form is, how to pull out a nice point and a slope. Likewise, with standard form, we have to recognize that standard form is the ax plus by equals c. We have to be able to pull out slopes and nice points. So, a couple of examples here. If I said I had 4x minus 3y equaling 9, I should be able to pull the slope out of this. The slope is found by taking the first number over the second and changing the sign. So in this case, it would be 4 over 3, and make sure that the slope is positive. 4 over 3. Notice that was a negative, the slope is positive. Then I need to find a nice point. If I plug a 0 in for x, I'm able to divide by negative 3 and get a nice result. So that's a nice point that I can graph. I plug 0 in for x. When I divide, I get negative 3 out for y. I have a nice point, I have a slope, I should be able to graph. Let's do another example of this. Let's say that I had 5x plus 3y equaling 20. I should be able to pull the slope out and get a nice point. So as I look at this, I'm going to take the 5 over the 3 for my slope, and then because this is a positive here, I want a negative. That tells me that these things never match. If there's a plus here, the slope is negative. So I took 5 over 3, changed the sign. This time as I try to throw a 0 in for the x, that doesn't divide nicely, and I need a nice point to plot on a graph. And so instead of dividing by the 3, I'm going to plug the 0 in for the y. And that allows me to divide by 5, and I get a much nicer answer. In other words, when I put the 0 in for x, I don't get a nice result. My next option is to plug the 0 in for the y. As I plug 0 in for y, I solve what remains, divide by 5, I get x being 4. That's a nice starting point. The next thing that we want to look at is the 3 types of outcomes that you can get when you are solving systems of equations. And so we have 3 outcomes that are possible. You can have lines that intersect at a point. Example, maybe I have a line that's shooting out like this, has a positive slope, and then I have another line that's coming down like that, I can find a point of intersection. That point of intersection in this case, maybe it's something like 5, 0. When you have two lines that intersect, you're looking for that coordinate pair, that ordered pair that shows where the intersection is. It's only one point that they have in common. And so we say lines intersect at a point. You get one answer. The second thing that can happen when you graph two lines, you might end up with what we call the parallel lines. Parallel lines will have the same slope. So as you work out the problems, you might see that you have something like this where the slope is, let's say, 2/3. And it goes through the point, I'm just making this up here, 0, 5. And then maybe as I work through the second equation, I get the same slope of 2/3, but it intersects the y-axis at -2. So they're two distinct lines. They'll never intersect because they have that same distance apart the whole time. The slope will never allow them to intersect. And so you say you have parallel lines, no solution. The third outcome we say is coinciding lines. It's very much like the parallel lines. You graph a line, and these lines can go any direction, doesn't really matter. On this one, let's say that the slope was 1/2, and it goes through 0, 3. Maybe I find out the same thing when I move to the second equation. It has a slope of 1/2, it goes through 0, 3, and so when I graph it, it graphs right over that first line. The idea here is that you have coinciding lines, meaning one lies on top of the other. There's an infinite number of solutions. We do not want to use the all reals idea. All reals would be a sweeping idea. It says that I have all of this shaded in, and that's not what we're doing here. We're saying we just share a line in common. So there is an infinite number of solutions. Real quick, I'll run through this one more time. The three outcomes that you expect as you're doing your homework. You can find a point of intersection. They have to be nice points. We have techniques for doing points that are a little less identifiable. And so what I'm saying here is you're going to have all integer answers. You know, -1, 2, 5, 0, 7, 3, you know, whatever. They have to be nice values. The second thing that could happen is your lines never intersect because they're parallel, which means you have no solution. And finally, the third outcome, you can have the same line. You graph a line, then you turn around, you graph the next line, it's the very same line. We say that those are coinciding lines, and there's an infinite number of solutions. That's our introduction to graphing systems of equations.